Hello everyone, in this video I will be solving Edexcel IAL P1 Jan 2023 paper WM1101. So let's get started. So the first question is from this chapter differentiation. So we have this equation and you need to differentiate this. So differentiation of 2 is 0 since we do not have any x related term. For the second and third one, we will use this formula. Differentiation of x to the power n is what? N x to the power n minus 1, right? So similarly, for this part, you will get half x to the power half minus 1. For the third one, 3 by 2 x to the power 3 by 2 minus 1. So if I simplify this, I will get 5x to the power minus half and 3x to the power plus half. So that's part A. Next, for part B, we need to find the exact value of the gradient. Gradient is basically dy by dx. We have this value of x, so I will just substitute the value of x in this expression. So dy by dx, if I simplify it a little bit, I get x by 5 by root x, as in this negative part, if I shift it at the denominator, it will be positive half, which is root x. So I will just substitute x equals to 2. So at x equals to 2, dy by dx is 5 by root 2 minus 3 root 2. So this is 5 root 2 by 2 minus 3 root 2. So 5 by 2 minus 3, this will give us minus half root 2. So you can just directly use the calculator to get to the final line. So that's it. We are done with part number 1. Next, let's move to number 2. So for number 2, you have this three different coordinates, point P, Q, and R. For part A, we need to prove that PQR is actually 90 degrees. So at the middle we have Q, so it means the right angle triangle should look like this, PQR. So we have a 90 degree over here at point Q. Since we know that for perpendicular line, the product of the gradient is minus 1. So I will just use the gradient of QR and PQ since these two lines are perpendicular. And I will check whether the product will give us minus 1 or not. So at first I will calculate the gradient of PQ. Gradient of PQ, the formula of the gradient is y2 minus y1 by x2 minus x1. So I'm using this coordinates of P and Q. So it's actually 11 minus 7, 9 minus, and we have a minus over here, so minus minus plus. So this will give us 4 by 12, which is 1 by 3. Next, we will calculate the gradient of QR. So I will use the coordinate of Q and R. So 2 minus 11, as in this y2 minus y1, then x2 minus x1, 12 minus 9. So you get minus 9 divided by 3, which is minus 3. So if this is m1 and that's m2, if I multiply this to m1 into m2, 1 by 3 into minus 3, I get minus 1. So yeah, PQ is perpendicular to QR, proving that PQR angle is actually 90 degree. You can even use the formula for Pythagoras. For that you need to calculate the distance of all the three sides. I use the concept of gradient. Next, for part B. For part B, we have fourth point S, and it is mentioned that PQRS, it is actually a rectangle, and you need to calculate the coordinate of S. So for part B, if I draw a rectangle P, Q, R, S, P is minus 3, 7, Q is 9, 11, R is 12, 2, and S, we do not know the coordinate of S. Let's assume it to be X and Y. So we need to calculate the coordinate of S. So for a rectangle, we know that the diagonals will intersect at the center of the circle. So at first, I will be using the coordinate of P and R to calculate the midpoint, coordinate of the midpoint, which is at the center. So let's denote it with M. So the coordinate of M will be, the formula for the midpoint is what? X1 plus X2 by 2, Y1 plus Y2 by 2. So I will be using P and R. So minus 3 plus 12 by 2, then 7 plus 2 by 2. So this will give us a coordinate of 4.5, 4.5. So next, so we know this coordinate 4.5, 4.5. So next I will use the same concept for this line SQ. So the midpoint of S and Q will be M, right? So X plus 9 divided by 2, as in coordinate of S and coordinate of Q. Average of this two will give us the coordinate of the center, which is 4.5. So if I simplify this, this will give us a coordinate of 0. Similarly, I will be using the y coordinates. So y plus 11, as in y coordinate of S, y coordinate of Q divided by 2. This will give us the y coordinate of the midpoint, which is 4.5. So the y coordinate is minus 2. Therefore, the coordinate of S is 0, minus 2. So this is the solution of part number 2. Next, number 3 is from the chapter integration. So the first step is to separate these fractions. So if I separate this, we get 4x to the power 4 divided by 2x squared. Similarly, 3 by 2x squared. So if I simplify it, I get 2x cubed, then 3 by 2, x to the power minus 2. Since I need to integrate, I'm supposed to have the x related term at the numerator level. So next, integration of x to the power n is what? X to the power n plus 1 by n plus 1 plus c, right? So 3 plus 1 by 3 plus 1 minus 2 plus 1 by minus 2 plus 1. Then since I have integrated in this line, so instead of this integration sign, I need to use a plus c over here. So 2 by 4 x to the power 4, 3 by 2 x to the power minus 1 by minus 1. So this will give us half x to the power 4 minus 3 by 2 x to the power minus 1 plus c. So done. This is number 3. Next we have number 4. This is a quadratic equation where coefficient of x square is a, then coefficient of x is actually b, then the constant term without any x is actually c. And it's already mentioned that the equation has no real roots. So for no real roots, b square minus 4ac is actually less than 0. So I will be substituting the value of a, b, c. So this will be 36k square (80 less than 0). Sorry, a is k, sorry, 4ac, so 4 into k into 5, so you get 20k. So if we had a 0 over here, this equation equals 0, then the two values, you can express them as k equals to 0 and k equals to 5 by 9. But since we have an inequality sign, as in less than sign, you have to arrange them in this range format. So we have to write this answer in a single range. So k greater than 0 but less than 5 by 9. The next question is number 5. We have this expression. We can replace 3 to the power x by p. So we need to simplify this and replace all the 3 to the power x by p, and eventually you will get this equation. So 5a So I'm just writing this equation from the question. So next, since p is actually 3 to the power x, I will be separating all this term and I will try to express 3 to the power x separately. So 9 can be expressed as 3 to the power x whole square, as in 3 square is 9. Then this can be written down as 3 to the power x into 3 square, since when terms are multiplied together, the powers are added, right? So 3 to the power x plus 2 can be written as 3 to the power x into 3 square. At the right side, you can separate this one also, 3 to the power x by 3 to the power 1. Since we have a minus, these two terms will be divided. So 3 to the power x whole square, 3 square is 9, 9 into 3 to the power x, 3 to the power x by 3. So I will just substitute p here. So this will be 3p square, 9p, 1 plus p by 3. So for simplification at the right side, it will be, we have 1 here, so 3 plus p, and at the left side we have an imaginary one, so you can just cross multiply this. So this will be 3p square 9p at the left side, and at the right side you have 3 plus p. So 9p square, 27p, 3 plus p. So 9p square, 27p minus 3 minus p equals 0. So this will give us 9p square, 26p minus 3 equals to 0. So let me check. Yeah, 9p square, 26p minus 3. So I'm done with part A. For part B, we need to solve this equation. So these two equations are the same, right? So I will just start part B using this equation. So for part B, 9p square plus 26p minus 3 equals to 0. So 9 3s are 27, so the middle term will look like this, 27p minus p, as in 27 into 1, and difference of this 2 should give us 26. Basic middle term equation thing. So from this first 2 term, I will just select 9p to factorize this, so you get p plus 3 and minus 1, so p plus 3. So this factor here is p plus 3, and then the remaining terms, as in 9p minus 1 in another separate bracket. So you get p equals to minus 3, p equals to 1 by 9. So since p is 3 to the power x, this is math error, you cannot solve this one. So I will just discard this value and select the second one. So 9 can be expressed as 3 to the power minus 2, right? As in 1 by 3 square, and when you shift this 3 square the numerator, you get a minus 2. So 3 to the power something, 3 to the power something. So if you compare the power, you get x equals to minus 2. Next, this is number 6, where you have the plan view of a design of a stage, which is consist of a sector and then 2 identical congruent triangles. The angle at the middle is 2.4. The area of this sector, it's given, area is 40. The AOD straight line is 12.5. This is 12.5. So if I divide this to this length equally, you get 12.5 divided by 2. So this will give 6.25, 6.25. That's the length of AO and OD. This O is the midpoint because these two triangles are congruent. So AO and OD should be equal. Okay, so let's start. For the first part, we need to calculate the radius. For part A, we need to calculate the radius. So area of the sector is what? Half r squared theta. Area is given. Theta is also given, 2.4. I'm selecting this sector. So 82.4 r squared. So solving this, we'll get root over 80 by 2.4. So r is actually 5.77, 2 decimal place, 5.77. For part B, we need to calculate the length of AOB. So if this is alpha, the right side is also alpha, so it's identical, symmetrical. So for part B, it's actually sum of these three angles should be 180, but since it's in radian mode, I need to write alpha plus 2.4 plus alpha equals to pi, as in radian mode 180 is pi. So you get 2 alpha plus 2.4. So from here you get pi minus 2.4 divided by 2, which is 0.371, but I need to write the answer in 2 decimal place, so 0.37. So I'm done with part A and part B. For part C, we need to find the total area. So for this one, I will just calculate the area of this triangles and then add the triangle of the sector. Okay, so this OB is the radius, right? So radius is 5.77, radius of the sector. So OB is 5.77. So if you just consider this triangle AOB, for any triangle the if you know the length of two sides and the angle. So area is half AB sine theta or half AB sine C, right? So similarly we have the sides 6.25 and 5.77. So I will just calculate the area. So half into 6.25, 5.77 into sine alpha. Alpha is what? Alpha is 0.37. So since these two triangles are identical, I will just multiply the whole thing by 2. So this gives us the sum of the two triangle areas, plus at the middle you have the sector area of which is given 40. So basically it's the triangle area into 2 plus the sector area. So from the calculator you will get the final result, which is 53.1 meters square. And obviously the calculator has to be in radian mode because the angles here are given in radian mode. For part B, we need to calculate the perimeter. So perimeter means the sum of the length of the boundaries. So if you actually analyze the shape, we have AD, then you have AB, then the arc length, then CD, right? So since I need to select the boundary length, AD is given 12.5, AB is something we need to calculate from the triangle AOB. So let me start with this one. So this triangle AB, and this one is O, right? Yeah, O. So AO is half of this 12.5. So 12.5 by 2 is 6.25. Angle AB, AOB, angle AOB is 0.37. We have already calculated that in part B, 0.37, and OB was the radius, which is 5.77. So from this triangle, using cosine rule for the side, as in a square equals b square c square minus 2bc cos a, using that formula you can calculate the length of AB. So 6.25 square, 5.77 square minus 2 into 6.25, 5.77 cos of 0.37, and then you just need to shift the square at the right side, which will be a root over of this entire equation. So from the calculator this will be 2.26. So this AB is 2.26, CD is also 2.26 because these two triangles are identical. And like I said, for perimeter you need to select the length of the boundaries. So we have this boundary 12.5, 2.26, 2.26. We still have this part, which is the arc length of the sector. Arc length, arc BC. Arc BC is actually r theta. Radius is 5.77, and this angle is 2.4. So this will give us 13.848. So the perimeter is 12.5, then 2.6, 2.26, then the arc length 13.848 plus 2.26. As in straight line, then the side of the triangle, then arc length, then side of the triangle. So 1, 2, 3, 4. This 4 length, you just add the 4 length. This will give us a value of 30.9. For number 7, we need to sketch the curve of 6 by x. So the sketch of 1 by x is actually like this. It's on the first and third quadrant, and this will be parallel to the y-axis and x-axis because we have azimuth at the x and y-axis. 6 by x is basically 6 into 1 by x, right? So the 1 by x graph will just be a little steeper. That's it. The shape and everything is same. It's just a steeper curve. That's it. So you can actually sketch 1 by x. It's similar to 6 by x. So that's the sketch. So this is part A. For part B, we need to describe this transformation and the rules. And the initial curve was 6 by x. This is transformed into a new curve, 6 by x minus 2. So if we had this minus 2 over here separately, then it's actually f of x minus 2, as in you are shifting the y coordinates. But since the minus 2 is at the denominator level, it's actually changing the x coordinate. So it's a horizontal translation. For negative, it's actually towards right. So I have a video for this kind of transformation concept. I will add the link in the description box, so you can cross check that. And here we have the x minus 2 thing. So it's actually translation of 2 units. Translation of 2 units to the right. For negative, it's actually towards right, as in for x related term, it's the opposite. If you have a plus 2, it goes towards left. For minus 2, it's towards right. So yeah, I'm done with part A and B. For part C, the curve, and we have the equation of the curve is this, the equation of the line is this, and this curve and line will intersect at 2 points P and Q. For intersecting point, we actually equate the equations, right? So I will just equate these two equations. So 6 by x minus 2 equals kx plus 7, and since coordinate of P is given minus 4, x coordinate is given, I will just substitute x equals to minus 4. So you get 6 by minus 4 minus 2, k into minus 4 plus 7. So at the left side you get minus 1. So k is actually 2. For part D, we need to calculate the coordinate of Q. So the line and the curve intersect at 2 points P and Q. For any intersecting point, you just need to equate the equation. So I will use this part, but this time I will use the value of k. So this will be 6 by x minus 2 equals k is 2. So 2x plus 7. So if I just cross multiply this thing, you get 6 by x minus 2. Sorry. At the right side, you have 1, imaginary 1, and then you just cross multiply this. You get x minus 2 into 2x plus 7 equals 6 into 1, which is 6. So at the left side, if I multiply this, you get 2x square plus 7x, and then minus 4x minus 14. So this is 2x square plus 3x, and then minus 6 minus 4 is actually minus 20. So if we need to factorize this for the middle term equation, so 2 into 20 is 40, then 2 10 2 5. So we need to use a combination, so the result is 3. So 2 to the 4, 4 to the 8, 8 and 5 gives us 3. So I will be using positive 8 and negative 5. So 2x square, positive x, negative 5. So from this first two term, if I factorize, two x, so x plus 4, then minus 5, x plus 4. So you get x plus 4 in one bracket and 2x minus 5. So basically x equals to minus 4. It's the coordinate of P. It was already mentioned. So the other x coordinate is supposed to be the x coordinate for Q. So we need to find the coordinates. So it means we will find the y coordinates now. So you can substitute the x coordinate in any of this equation. The y coordinate 6 by x minus 2. So x minus x is 5 by 2. So the answer is 12. So Q is 5 by 2, 12. So that's number 7. Next, for number 8, we have this quadratic equation. The line L cuts the y-axis as at minus 12, as in this point. It's actually 0, minus 12, and cuts the x-axis at 4. So this is actually 4, 0. So the y coordinate and the x coordinate is given. We need to calculate this line equation. So if you know the coordinate of 2 points, we can calculate the equation of the line. So at first I will calculate the gradient, y2 minus y1. So wait, the coordinates are what? 0, minus 12, and 4, 0. So we need to find the equation of the line. At first I will just calculate the gradient. So y2 minus y1, x2 minus x1. So 0 minus will give us 12, then 4 minus 0. So the gradient is 3, and the equation of the line is y minus y1, gradient x minus x1, right? The gradient is m, and any point you can select. So suppose I am selecting 4, 0, this one. So y minus 0, x1 is 4, y1 is 0. M is the gradient, which is 3. So x1 is 4, y1 is 0. So x is 4. So it's 3x minus 12. That's the equation of the line. Next, for part B, we need to calculate the value of k. The equation, we need to calculate the value of k. The equation of the curve is f of x. The minimum point is 7 minus 8, this one. The curve intersect at x-axis at 4 and k. Okay, so the curve intersects the x-axis. This is the curve, and the intersecting points are 4 and k. It is already mentioned, the curve cuts the x-axis at 4 and k. So this is 4 and this is k, as an intersecting point of the curve with the x-axis. And we know that for the quadratic curve, it is a symmetrical U-shaped curve, and the midpoint is at the center, right? The The midpoint is at the middle. The minimum point is at the middle. So if you take the average of this 2 point, then you will get the coordinate of the midpoint. So this is actually 4 and this is k. So if I need to find the coordinate of the minimum point, it's supposed to be the average of these two. So at the middle, the x coordinate is 7, right? So 7 should be the midpoint of this 2. So it's actually 4 plus k divided by 2, as in x1 plus x2 by 2. So k is actually 10. So that's part B. For part C, we need to find the equation of this curve. So this is actually 4. So this factor is actually x minus 4. And this is 10k. So from here you get x minus 10. So the two factors of this equation are x minus 4 and x minus 10. So for any quadratic equation, when you simplify, you get the factors, right? So for this problem, we already know the factors, which is x minus 4, x minus 10. When you factorize, there could be another extra constant here, which for the time being we do not know. So let me just assume it to be a. So this could be the equation y equals to a into x minus 4, x minus 10. The unknown term a, we need to find the value of a. So you can select any point from the curve. So let me select the minimum point. So 7 minus 18. So I will just substitute this x and y coordinate. So x is 7. So minus 8, 3, minus 3. So from here you get a equals to 2. So the equation is 2, x minus 4, x minus 10. Next we need to describe the inequalities. Okay, so of this shaded region. So this is bounded by 3 separate 2 lines and 1 curve. So this y-axis is actually x equals to 0 and the shaded region is towards right, so it's actually x greater than 0. Then the equation of the curve is 2x minus 4, x minus 10, but the shaded region is below the curve, so that's why it will be less than 0. Then the line, the equation of the line is actually y equals 3x minus 12, and since the shaded region is above the line, so it should be greater than. So these are the inequalities that describe the shaded region. So you just need to select the you just need to analyze the position. If it's towards right, use greater than sign. If it's towards left, you use less than. Then if it's above, then you use greater. If it's below, you use the less than sign. So let's start number 9. So this one is a sketch of y equals to 10x and y equals to pi x. So for this one, we need to have a basic idea about the 10x curve. So I will just add the asymptotes here. So for a graph of 10, we have a cutting point at 0, and then the asymptote is at 90. Similarly, at the left side, we have a negative asymptote of minus 90. This cutting point is 180. This one is minus 180. For part A, we need to find the period of tan x. Tan x curve is just a repetition of one single cycle, right? Depending on the range, you just replicate the entire thing, both at the right side and the left side. But the basic curve of tan x is this part, right? This one complete cycle takes about 180 degree, plus 90 minus 90. If you add them up, you have a gap of 180. So this 180 is the period of tan, as in one complete cycle. Since the values are given in radian mode, I need to write pi. Pi is 180 degree, equivalent to 180 degree in radian mode. Next, for part B. Part B, we need to find the number of roots of tan x and pi plus 2x within a range of minus pi to plus pi. So minus pi means minus 180 to plus 180. Okay, so the curve is already given within this range of minus pi to plus pi. Okay, so the curve, the straight line given is actually pi x, but we need to work with pi plus 2x, but both of them are similar. Okay, both of them are similar. We need to find the number of roots, means we need to find out the number of intersecting point. The given equation, the given line actually intersect with the tan x curve at 3 different points. This line will also intersect at 3 different points. So let me just show you how. This line has a gradient of pi, whereas the line we need to work with has a gradient of pi plus 2. So if I use numerical values, suppose 3.142 x, and this one is actually 3.142 plus 2, so 5.142 x. So this is also a straight line passing through origin, but with a greater gradient, right? So this line you do not need to sketch. Let me just show you here, just for a better understanding, so that you can imagine it. I am just drawing the new line with a greater gradient. So since the gradient is greater compared to the original line, it will be a steeper line. So it doesn't matter, the intersecting point remains same, 1, 2, 3. So we have 3 intersecting points. So the answer to part B1 is actually 3. 3 intersecting point represents number of root is 3. Again, so next we need to solve tan x equals to pi x for a range of minus 2 pi to positive 2 pi, as in 360 and minus 360. So it means we need to work with a greater range. So I need to extend the curve on both right side and left side. So I am removing the portion for part B1. Since I need to work with a range of minus 360 to plus 360, I will just extend the curve. So this one, if I extend this from 180 at a difference of 90, we have the next asymptote. So the next asymptote here will be at 270. And if I continue with the next cycle, this will intersect at 360. So I won't be taking the extra part because I need up to 360. Similarly, at the left side, I will continue this part, and the asymptote will be at negative 270. And if I continue the next cycle, I will remove this as I need up to minus 360. Okay, so this is actually minus 2 pi and that's plus 2 pi. So I have already I have the sketch of tan x within a range of minus 2 pi to plus 2 pi. Now I just need to find the intersecting point of this curve with the line. Okay, so for that you need to extend the line so that you can get all the intersecting points, right? So extend the line as much as possible. So I will extend it at the right side of y-axis. Similarly, I will extend it at the left side of y-axis. Not just the line, you need to extend the curve also, because we are sketching for a minimum space, but it will go up to infinity, right? So when it goes up, we have intersecting point here. Similarly, when it goes down, we have another intersecting point. Okay, so you can even extend this, but since we won't have any cutting point here, I'm not wasting time there. So the total intersecting point here is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the intersecting point between tan x and y equals to pi x, the given line between a range of minus 360 to plus 360, is actually 5. So that's the answer for B2. For the next one, B3, tan x pi x, it's the same thing, right? But just the range is greater. It's just that we have a greater range. Instead of 2 pi, it's actually 100 pi, which is 50 times of the previous one. Similarly, at the negative side, it's 50 times of the previous one. So we do not, it's not possible to actually sketch up to 100 pi, right? So I will just try to analyze the pattern and replicate the same thing. So the main idea is that the line here, as you can see, will intersect at the center once. Okay, the line will intersect at the center once, here only once. And then let me just discuss this portion, 0 to 2 pi. In this part, it will intersect at two different points, 1, 2. It will intersect at two different points. So if I actually replicate for the next 360, for next 2 pi, you will have two more extra points. For the next 2 pi, you will have two more extra points, as in within a gap of 2 pi, within a gap of 360 degree, the curve will intersect twice with the line. And in this part, we have two cutting points, and since we need to go up to 100 pi, it means you need to replicate this 50 times. So we will have a core point of 100 points, 2 into 50. Similarly, at the left side, just like I said, we are not talking about the origin. You cannot just multiply the origin point into 5. We do not have 5, we do not have 50 origins. We only have one origin, and the line will intersect the origin only once, but as it goes up, it will cut twice within a range of 360. For every single 360 cycle, we will have two more extra points, but not for the origin. At the origin, you will only have one single point, so it's fixed. So at the left side of the origin, this portion, you have two intersecting points, right? You have two intersecting points, 1, 2. So this is for a range of 0 to minus 2 pi, as in 2 pi gap. So if I replicate this, for the next 2 pi, you will have two more points. For the next 2 pi, you will have two more points. In short, it will be 2 into 50 at the left side. So in short, we will have one single point at the origin, at the right side of the origin. For each 360, for each 2 pi, you will have two intersecting points. And since we need to find up to 100 pi, so it will be repeated 50 times. This is similar at the left side. So 2 into 50 at the left side. In total, we will have 210 points. So that's the solution of number 9, P1 Jan 2023. Next is number 10. Here we have a cubic curve, and the equation of the curve is given. We need to find the values of x for which the curve is greater than 0. So for that, we need to find the intersecting points first, the intersecting point of x. So at x-axis, y equals to 0. If you solve this, you get minus 20 by 3, minus 6, and then 3 by 2, right? 3 by 2. So if I draw this here, this point is minus 20 by 3, this is minus 6, and this is 3 by 2. We need to consider the curve above x-axis, because f of x greater than 0 means y greater than 0, means y has to be positive. and y is positive above the x-axis, So the portion above x-axis is this part and this part. So if I need to explain the range for this portion only, x is greater than 20/3 and less than -6, and for this part it's towards right of 3/2, right? This is 3/2, so it's greater than 3/2, because less than 3/2 means at the left side. We are not talking about this. We need to take the portion above x-axis. So this is the part we need to select. So x has to be greater than 3/2. So that's the result. -20 greater than -20/3, less than -6, and then x is greater than -3/2. X is greater than 3/2. So that's the answer for 10A. -20/3, -6, and greater than 3/2. For part B, we just need to expand this expression of f of x. So it's just that we need to simplify it, nothing else. So if I keep this thing here and multiply this two brackets, you get something like this. Simplifying this will give us 9x, and then you multiply 3. So you in this line you just need to simplify it. So when you multiply these 3 terms with 3, you get this part, and then when you multiply 20 with this 3, you get this part, and then after simplifying this, you will get the final result of f of x. That's the equation of f of x. For part C, the straight line L is a tangent to the curve, where the curve cuts the y-axis. At y-axis, x equals to 0. As in, we are talking about this point. This point, the line cuts the curve at this point at the y-axis. So at y-axis, x equals to 0. So I will just substitute x equals to 0 in this equation. At y-axis, x is 0. So if I actually substitute 0, 0, 0 in the equation of f of x, you can even select this part. You can even select this equation. So if you substitute x equals to 0, here you will get a y coordinate of -360. So when you substitute x equals to 0 into the equation of y, you get -360. So that's the coordinate 0, -360. So this is the coordinate 0, -360. So we need to find the line L is a tangent. This line which passes through this point it's a tangent. It's a tangent, and this will cut the curve at point P. We need to find the x coordinate of P. So we will just try to find the equation of this line, and then P is just the intersecting point, right? We need to find the x coordinate of P, whereas P is the intersecting point of line and the curve. So we will just solve simultaneous equations. We will solve the equation of the curve and the equation of the line. So equation of curve is given. We will try to find the equation of the line. So this equation, this line passes through 0 and -360. So this is my x1, y1. I will try to find the gradient. So y is the equation of the line. So if I differentiate this, so I'm just using the equation simplified version from part B. So we need to find the gradient. So for that we will find dy by dx. So from here you get 3x squared, 67, 2x, 126, and this becomes 0. So dy by dx is 18x squared 134x, 126. Okay, so we need to find the gradient at x equals to 0. So x equals to 0, dy by dx is actually 18 into 0, 30 is 0 plus 0 plus 126. So this is the gradient. This is the gradient, and we will try to find the equation of this line. Formula is y minus y1 gradient x minus x1. This is x1 y1, and that's the gradient. So I will just substitute it here. Y1 is minus 360, minus minus plus. Gradient is 126, x is 0. So this is actually 126x minus 360. That's the equation of the line. And we need to find the coordinate of P, right? Coordinate of P, which is the intersecting point of the line and the curve. So this is the equation of the line. As you can see, this is the line and that's the curve, and P is the intersecting point of the line and the curve, right? So this is the equation of the curve, and this is the equation of the curve. This is the equation of the line. So I will just use these two equations. I will equate them and solve this. So 6. So this is the continuation of part C here. So 6x cube, 67x square. So I'm just using the equation of the line and the curve. I'm equating them. So as you can see, this are cancelled out. We are left with 6x cube, 67x square equals 0. Then x square, 6x plus 67. So x is 0, x is minus 67 by 6. There are two intersecting points. The line and the curve intersect at 0. This point here, x equals to 0. As in, this is a point where x equals to 0, and we are talking about this one, P. So x is 0, we need to discard this. This is the value we need to work with, right? So x equals to minus 67 by 6. So this is the x coordinate of point P. So we are done with number 10. So we are left with number 11 only. So for number 11, this is f double prime, as in initially the equation of the curve is f of x. When you differentiate this, you get f prime x. When you differentiate again, as in the second derivative, it becomes x double prime x. And we know that if we need to go back, we need to integrate, right? We integrate and we go back from prime to normal equation. Okay, so first of all, this is the equation of the curve. Point P has a coordinate of x, 4. The tangent to P has the equation of this. Okay, at first we need to find the equation of the normal at point P. Okay, so normal is just a straight line, right? For any curve, gradient of the tangent can be used to find the gradient of the normal. So this is the tangent, and the normal is a perpendicular line. So if we know the gradient of the tangent, we can use the formula m1 m2 equals minus 1, because normal is just a perpendicular line, right? So the tangent equation is already given. If we compare this with the general format, y equals to mx plus c, the gradient of this tangent is actually 3, right? So gradient of tangent is 3, but we need to find the equation of the normal, so that's why I will convert this gradient as in reciprocal, negative reciprocal. You can directly use minus 1 by 3, or you can also show these steps. And next we need the coordinate. X coordinate is given, so if we substitute x coordinate in this equation, this becomes y equals 3 into 4 plus 4, so 16. So the coordinate is 4, 16. So now I know the gradient of the normal, I know the x1, y1, the coordinate. So to find the equation, the formula is y minus y1 gradient x minus x1. So y minus 16 gradient is minus 1 by 3 x minus 4. Sorry, yeah, x minus 4. So if I simplify this, y minus 16 minus 1 by 3x plus 4 by 3. So it's actually minus 1 by 3x plus 52 by 3. So I'm done with part A. Next, for part B, we need to find the equation of f of x. When you integrate f double prime, you get f prime, and then when you integrate f prime, you will get the original equation f of x. So let me start with this equation first. So f double prime, as given in the equation here, in the question, 4x, and if we shift root x at the numerator, you get x to the power minus half. So 4x x to the power minus half. So this is given. So if I need to find f prime, we need to integrate this expression. So you get 1 plus 1 by 1 plus 1. You get minus half plus 1 by minus half plus 1 plus c. And f prime x is what? Dy by dx, right? F of x is actually y. When you differentiate it, you get dy by dx, which is actually f prime x, right? So f prime x is basically the gradient, which we already know. The gradient is what? Gradient is 3. Gradient of the tangent. Gradient of the tangent is 3. So gradient is 3. It means f prime is 3. And when x equals to 4. So we can use those boundary condition. So when x equals to 4, the gradient f prime is actually 3. So let me just simplify a bit. So this is 4 by 4. So 2x square. Then x to the power half divided by half. So 1 divided by half is actually 2. So 2 to the power half plus c. So if I substitute this, so 3 equals 2, 4 square plus 2, 4 to the power half plus c. So you get 3, 32, 2 to the 4 plus c. So you get c equals minus 33. Okay, so if I use this equation, I will substitute c here. So f prime x now is actually 2x square, 2x to the power half plus c, but I will use the value of c, which is minus 33. So we have the equation for f prime x, and if we need f of x, obviously you need to integrate at the right side. So f of x is what? F of x is the main equation, which is y, right? And at the right side you get 2 cube divided by 3. Then this one is half. Half plus 1 is 3 by 2. So 3 by 2 divided by 3 by 2 minus 33x plus, instead of c, I will be using a new variable, suppose p, because we have already used the constant c here. So use a second one here. So this is actually 2 by 3 x cube, then 2 by 2 by 3, which is 4 by 3, minus 33x plus p. So when we find the value of p, we will get the final result. So you can use any coordinate you know. So we know the coordinate 416, right? The curve passes through 416, so that's why I will be using x equals to 4 and y equals to 16. So substitute that into this equation. So 2 by 3 16 cube, sorry, x coordinate is 4, so 4 cube, 4 by 3, 4 to the power 3 by 2 into 4 plus p. So when you simplify this, you will get the value of p, which is 284 by 3. So the equation f of x can be expressed now including the value of p. So 2 by 3 x cube, 4 by 3 x to the power 3 by 2, 33x plus 284 by 3. That's the last line. So I'm done solving the IAL P1 Jan 2023 paper, and since I have just solved the problems but didn't discuss the theoretical part or the formula, the derivation and all for each topic, you can review the concepts, the basic concepts and the formulas. So I will add the individual links and the playlist link in the description box. You can check out those videos and clear the concepts for individual topic. That will help you while solving the past papers. So see you in the next video. Till then, take care. Bye bye.